January 1944. Before dawn, the factory lights are already on. Cold air hangs over the concrete apron as a single aircraft rolls out of a vast assembly hall. Its skin is still warm from curing paint. Rivet seams catch the light. Mechanics step back, clipboards tucked under their arms, watching another finished machine move toward the runway. Inside the building, the noise does not stop. Conveyor lines advance with steady patience. Engines arrive on carts. Wings descend from overhead cranes. Every motion is practiced, measured, repeated. Outside, the war is grinding forward in Europe and the Pacific. Loss reports are arriving daily. Aircraft are being destroyed faster than any nation once believed possible. Before the war, planners in Berlin and Tokyo dismissed American factories as inefficient, soft, untested by real pressure. Here, there is no speech. No celebration. Only output. By the end of this day, this same factory will complete enough combat aircraft to replace an entire frontline squadron. By tomorrow, it will do it again. And the quiet certainty of that rhythm, steel, labor, time, will begin to change the mathematics of the war itself, forcing the enemy to confront a reality they never truly calculated. In the years before the war, the United States was not feared as an industrial juggernaut. It was seen as distant, divided, slow to mobilize. In 1939, when war erupted in Europe, American factories were still operating on peacetime logic. Aircraft plants produced in small batches. Military contracts were limited. Congress debated budgets while isolationist sentiment dominated public life. The U.S. Army Air Corps ranked far below European air forces in size, experience, and readiness. German planners watched carefully. So did Japanese naval intelligence. What they saw did not impress them. American industry, they believed, lacked discipline. Its workforce was fragmented by labor disputes. Its production methods were commercial, not martial. Assembly lines made refrigerators and automobiles, not weapons for sustained war. Even as late as 1940, German intelligence assessments described U.S. aircraft output as numerically impressive on paper, but structurally inefficient in practice: too many models, too much customization, too little standardization. This belief was not entirely irrational. Before 1941, the United States produced fewer than 3,000 military aircraft per year. By comparison, Germany and Britain were already operating at war tempo. Japan, though limited in raw materials, had optimized production around naval aviation and long-range strike aircraft. America, meanwhile, was still debating whether it would fight at all. Factories were geographically dispersed. Supply chains were civilian-oriented. Skilled aviation labor was scarce. Many plants had never produced combat aircraft in volume. In the eyes of Axis planners, this meant one thing: even if America entered the war, it would take years before its industry could matter. The assumption hardened into doctrine. German air strategy relied on the idea that enemy aircraft losses would eventually exceed replacement capacity. Japanese planners believed a decisive early blow would cripple American ability to recover. Both rested their calculations on attrition curves that assumed American output would remain limited, fragile, and slow to scale. Then came December 1941. The entry of the United States into the war did not immediately overturn those assumptions. Early American deployments were small. Aircraft losses mounted quickly in the Pacific. Training accidents were frequent. Production bottlenecks appeared everywhere: engines, aluminum, skilled mechanics. To Axis observers, the pattern looked familiar. A large nation struggling to convert potential into performance. What they could not see yet was what was happening behind factory walls, how those early failures were not signs of weakness, but symptoms of something reorganizing itself at a scale the modern world had never attempted. And as contracts multiplied and blueprints were simplified, the transformation quietly began to accelerate, setting the conditions for a shift that would soon overwhelm every pre-war estimate. The shift did not happen overnight. It happened by design. In early 1942, the United States government began dismantling the peacetime logic that had defined its industry for decades. Civilian production schedules were suspended. Automotive plants were converted. Aviation contracts were rewritten with a single priority: volume over elegance, replacement over perfection. The War Production Board imposed order where fragmentation had once existed. Aircraft designs were frozen to prevent constant modification. Tooling was standardized. Parts were made interchangeable across factories separated by thousands of miles. The emphasis moved away from craftsmanship toward repeatability. This was not glamorous work. It was administrative, procedural, relentless. Factories expanded outward instead of upward. New assembly halls were built with straight-line layouts to eliminate wasted motion. Subcontractors were folded into centralized schedules. Aluminum allotments were calculated down to the pound. Engines were produced in parallel, not sequentially. Delays were no longer tolerated as inevitable, they were mapped, measured, and eliminated. The workforce changed just as radically. Millions of Americans entered industrial labor for the first time. Farmers, clerks, students, and machinists were trained in weeks, not years. Women moved into skilled positions once considered inaccessible. Training manuals replaced apprenticeship traditions. Tasks were broken down so precisely that a single worker might repeat the same motion thousands of times per week. This was not chaos. It was industrial discipline on a national scale. By mid-1942, aircraft output had already surpassed pre-war totals. In 1943, it multiplied again. Entire airframes moved through factories on timed schedules, measured not in weeks, but in hours. A wing no longer belonged to a single airplane, it was a component in a flow, part of a system designed to never stop moving. One factory in particular embodied this transformation. Built for speed, scale, and simplicity, it was designed to produce aircraft as if they were industrial commodities rather than handcrafted machines. Its layout eliminated bottlenecks before they could form. Its supply lines were synchronized with railroads, engine plants, and testing fields. Its workforce operated around the clock in shifts that blurred night and day. Loss reports from overseas were now factored directly into production targets. Aircraft destroyed in combat were no longer treated as setbacks, but as variables. Replacement rates were calculated to exceed attrition by design. Axis intelligence struggled to interpret what was happening. Reports conflicted. Numbers seemed exaggerated. Production claims appeared implausible when compared to European experience. But the data was real. By late 1943, American industry was no longer trying to catch up. It was accelerating past every model used to predict wartime sustainability. And as this one factory approached a daily output once thought impossible, the balance between loss and replacement quietly tipped, setting the stage for the moment when production itself would become a decisive weapon. The transformation of American industry can be measured in numbers. But it was carried forward by people. Inside the factory, the workforce did not look like a traditional military force. It was older, younger, more diverse. Many had never seen an aircraft up close before the war. They learned not through speeches, but through repetition, hands guided by jigs, movements paced by conveyors, standards enforced by gauges rather than intuition. Fatigue was constant. So was turnover. Yet the system absorbed both. Individual weakness no longer halted production, because the process itself carried the load. This was the human angle of industrial war. Not heroism in the conventional sense, but endurance. Thousands of small actions, performed correctly, hour after hour, creating machines that would never return. The technological angle followed naturally. Aircraft were redesigned for production, not just performance. Complex curves were flattened. Parts were reduced. Access panels were enlarged to speed assembly and maintenance. Components were standardized so they could be installed by less experienced hands without compromising reliability. Engineering decisions were no longer judged solely by aerodynamics, but by how fast a design could move through a factory. Leadership enabled this shift. Civilian executives, military planners, and engineers coordinated at a scale unseen before. Decisions that once took months were reduced to days. Production targets were enforced with the same seriousness as operational orders. Failure to meet quotas carried consequences, not symbolic, but logistical. The goal was not prestige. It was continuity. Even so, the system was not without strain. Machines broke. Workers collapsed from exhaustion. Quality control caught errors only inches from catastrophe. But unlike pre-war industry, these failures were treated as data, not disasters. Each interruption refined the process further. What made this approach so dangerous to America's enemies was not speed alone, but predictability. Output could be forecast. Replacement schedules could be planned months in advance. The factory did not respond emotionally to battlefield losses, it absorbed them mathematically. And while pilots overseas counted their remaining aircraft, few of their adversaries yet understood that behind the front lines, replacement had already become routine, steady, and increasingly unstoppable. That realization, still incomplete, still resisted, would harden as enemy intelligence began confronting numbers that no longer fit their assumptions. From the enemy's perspective, the evidence arrived slowly, and was often dismissed. German and Japanese intelligence services collected fragments, shipping manifests, aerial reconnaissance, intercepted reports. Individually, none seemed decisive. Together, they pointed to a level of output that defied European experience. Factories of that size, producing aircraft at that tempo, were unprecedented in Axis industrial planning. German strategists had built their air war models on replacement parity. Aircraft losses were assumed to matter only if they exceeded production. But their calculations were grounded in familiar limits: skilled labor shortages, tooling constraints, time-intensive craftsmanship. The American system did not follow those rules. It bypassed them. Japanese planners faced a similar blind spot. Their aircraft industry prized precision and performance, but depended on small runs and highly trained specialists. Replacement aircraft arrived slowly at forward units. Attrition could not be ignored. When reports suggested that American squadrons were being replenished almost immediately after heavy losses, the explanation was often attributed to exaggeration or misreporting. Morally and psychologically, this gap mattered. For pilots and ground crews facing American airpower, destruction no longer carried the reassurance it once had. Aircraft shot down in the morning seemed to reappear weeks later in equal or greater numbers. Airfields that should have been exhausted remained active. The expected pause, the breathing space that attrition was meant to create, never came. Operationally, this changed everything. American commanders could plan offensives without conserving aircraft in the same way their enemies did. Training units were fed by the same industrial flow as combat squadrons. New pilots arrived knowing that replacement aircraft would be available. Losses were tragic, but they no longer threatened collapse. Behind this confidence was the factory. Its daily output, measured, audited, verified, quietly exceeded the theoretical strength of a frontline squadron. Not once, but repeatedly. The math was inescapable: even sustained losses could be absorbed without slowing operations. By the time enemy analysts began revising their assumptions, the system was already mature. Production curves had flattened at high volume. Bottlenecks had been eliminated. The machinery of replacement was no longer experimental, it was routine. And as this reality converged with combat reports from multiple fronts, the war approached a moment where industrial momentum, not tactical brilliance, would decide what could no longer be reversed. By the winter of 1943, the numbers stopped being theoretical. Production logs, inspection records, and delivery schedules began to align in a way that no longer allowed for optimistic interpretation or statistical noise. At one American aircraft factory, output reached a pace that planners had once treated as an upper fantasy limit. Finished aircraft were leaving the line not by the week, but by the hour. A squadron, by standard wartime definition, consisted of roughly a dozen frontline aircraft. Some were larger, some smaller. But the concept was fixed: a discrete, operational unit, trained together, deployed together, and expected to absorb losses over time. This factory was now replacing that entire unit in a single day. The implications were immediate and profound. Losses that once required months to recover from could now be offset within a production cycle measured in hours. Attrition curves, long used to predict when air forces would weaken or collapse, began to fail under the weight of replacement volume. Combat reports from Europe and the Pacific reflected this shift almost simultaneously. Squadrons rotated aircraft without grounding. Units that had suffered heavy losses were re-equipped before morale could fracture. Aircraft types that had been scarce a year earlier were now arriving in steady, predictable streams. The factory floor did not react to these developments. It did not speed up in response to victories or slow down in response to setbacks. It maintained pace. Each completed airframe passed through inspection, test flight, and acceptance with minimal delay. Engines were swapped without halting the line. Damage discovered during testing did not stall output, it was routed around, corrected downstream, and fed back into the system. Enemy intelligence finally began to adjust. Reports acknowledged that American aircraft losses were no longer translating into operational decline. Attempts to quantify production struggled to keep up with verified deliveries. Estimates were revised upward, then upward again. What had once been dismissed as inefficiency was revealed as something else entirely: an industrial model that treated war as a problem of sustained flow rather than decisive scarcity. And as daily production crossed the symbolic threshold of squadron replacement, the war entered a phase where destruction alone could no longer promise advantage, only delay. The decisive change was not visible in a single battle. It emerged across calendars. By early 1944, American air operations were no longer constrained by replacement anxiety. Planning documents reflected a new confidence, one rooted not in optimism, but in production certainty. Aircraft losses were anticipated, calculated, and absorbed into operational schedules. The limiting factor was no longer machines. It was aircrew training and forward basing. This marked a fundamental reversal. For years, air warfare doctrine had assumed that sustained attrition would eventually force pauses. Aircraft required time to build. Skilled labor could not be rushed. Industrial fatigue would set in. These assumptions shaped Axis strategy from the opening days of the war. They were now obsolete. In Europe, long-range bombing operations intensified. Aircraft dispatched on deep missions returned with predictable loss ratios and predictable replacements. Damaged airframes were written off without hesitation, knowing their absence would not reduce sortie strength. New aircraft arrived at depots already earmarked for specific units, their serial numbers logged before the previous week's losses had even been fully assessed. In the Pacific, distances magnified the effect. Aircraft ferried across oceans arrived faster than enemy planners believed possible. Island airfields that should have represented the end of logistical reach instead became permanent launch points. Attrition no longer thinned American presence, it tested the limits of enemy interception. The factory at the center of this shift continued its routine. Production records showed consistency rather than spikes. Output did not surge briefly and collapse. It stabilized at a level once considered unattainable. Each day's total fed directly into strategic models that assumed continuity rather than recovery. This continuity reshaped command decisions. American planners could commit airpower repeatedly, knowing that losses would not compromise future operations. Enemy air forces, facing the same attrition without comparable replacement, were forced into conservation. Aircraft were withheld. Pilots were grounded. Initiative narrowed. By the time Axis leadership fully accepted what the numbers meant, adaptation was no longer possible. Factories could not be rebuilt at scale under bombing. Training pipelines could not be accelerated without sacrificing safety and skill. Resource shortages compounded the imbalance. The turning point had passed quietly, without a single announcement, without a single decisive strike, marked instead by production charts that no longer bent downward under pressure. And with that shift secured, the consequences began unfolding across every front, as replacement became permanence, and permanence became dominance. The effects of this shift were felt first in tempo. American air units no longer measured success by how long they could conserve strength, but by how continuously they could apply pressure. Aircraft availability ceased to be the primary constraint. Operations followed one another with little pause, compressing enemy recovery time and forcing constant reaction. In Europe, this manifested as sustained aerial presence. Bombing campaigns no longer rose and fell with replacement cycles. Aircraft losses, once expected to thin formations and slow operations, were absorbed almost invisibly. Squadrons rotated machines while maintaining operational readiness. Maintenance units worked against a stable flow of replacements rather than an uncertain backlog. For enemy forces, the contrast was stark. German air units, already strained by fuel shortages and pilot losses, faced an opponent whose numbers did not decline in proportion to effort. Interceptions that destroyed several aircraft produced no lasting effect. The next wave arrived on schedule. The strategic logic that had once justified heavy expenditure of fighters, trading aircraft for time, collapsed when time itself stopped being gained. In the Pacific, the consequences were equally decisive but expressed differently. American airfields, once vulnerable due to distance and supply constraints, became resilient nodes. Aircraft losses during island campaigns no longer threatened air superiority. Replacement aircraft arrived quickly enough to maintain continuous coverage. This allowed commanders to press forward without waiting for rebuilding phases that had once defined operational rhythm. The psychological impact compounded the material one. Enemy pilots and ground crews encountered a pattern they could not reverse. Destruction no longer promised relief. Each engagement felt increasingly futile, not because American aircraft were invulnerable, but because they were inexhaustible. Morale suffered as effort failed to translate into advantage. Behind this pressure stood the same constant, industrial predictability. The factory's output fed into global logistics networks with minimal disruption. Aircraft moved from production lines to training units, then onward to combat zones in a steady progression. Losses became accounting entries rather than crises. By mid-1944, the imbalance was no longer a matter of debate. It was reflected in sortie rates, airfield density, and operational reach. The enemy still fought fiercely, but now against a system that replaced strength faster than it could be reduced. And as these consequences accumulated across months of sustained operations, the war entered a phase where the outcome was shaped less by isolated engagements than by the irreversible weight of replacement itself. As the months passed, the consequences extended beyond the battlefield and into the structure of warfare itself. Enemy attempts to adapt came too late. German industry, increasingly fragmented by bombing and constrained by fuel shortages, could not replicate the American model even in theory. Factories were dispersed for survival, not optimized for flow. Skilled labor was siphoned into the military. Designs became more complex in pursuit of marginal performance gains, further slowing production. Each new aircraft demanded more time, more precision, and more resources than the last. Japan faced an even harsher reality. Material shortages, limited industrial depth, and long supply lines prevented any meaningful increase in output. Training pipelines narrowed as experienced pilots were lost faster than they could be replaced. Aircraft that reached frontline units often did so without sufficient spare parts or fuel. Attrition, once expected to favor decisive engagements, instead hollowed out capability. In contrast, the American system matured. Factories refined processes rather than expanding recklessly. Quality stabilized at high volume. Production errors decreased as repetition eliminated variation. Aircraft types were produced in long, uninterrupted runs, allowing logistics, training, and maintenance to synchronize seamlessly. The factory that once shocked planners with daily squadron-level output now served as a model replicated across the country. This had lasting strategic effects. American commanders could plan campaigns assuming air superiority as a constant rather than an objective. Air cover was not something to be achieved and protected, it was something that arrived with the force. This reduced operational risk, shortened timelines, and allowed coordination between air, land, and naval units at a scale that overwhelmed enemy defenses. The war's later stages reflected this imbalance clearly. Airfields multiplied. Carrier decks remained stocked. Replacement aircraft arrived faster than losses could reshape force composition. Even catastrophic engagements failed to disrupt continuity. What had once been a vulnerability, dependence on industrial output, became a source of invulnerability through excess. By the time the war approached its conclusion, the factory's role was no longer debated. It was acknowledged in reports, production summaries, and post-war assessments as a decisive contributor, not because it produced a single superior machine, but because it produced relentlessly. And as historians later examined how the conflict's momentum became irreversible, they returned again and again to this realization: once replacement exceeded destruction by design, the outcome no longer hinged on individual battles, but on time itself running out for those who could not keep pace. In the end, the factory never appeared on a battlefield map. It had no front line. No defensive perimeter marked by trenches or guns. Its victories were recorded in ledgers, shift schedules, and production tallies rather than after-action reports. Yet its influence reached every theater of the war. What this moment revealed was not simply the strength of American industry, but the changing nature of modern conflict. War was no longer decided solely by brilliance in command or courage under fire. It was shaped by systems, by the ability to organize labor, resources, and time into something that could endure longer than an enemy's capacity to resist. The belief that American industry was soft had rested on an outdated idea of strength. It assumed that efficiency looked like craftsmanship, that discipline required hierarchy, and that scale introduced fragility. The factory proved otherwise. It demonstrated that resilience could be engineered, that endurance could be standardized, and that replacement itself could become a weapon. For the men who flew the aircraft and the workers who built them, this reality carried a quieter meaning. Every completed airframe represented effort spent far from the front, yet bound to it. Every loss in combat was met not with despair, but with continuity, another machine already moving down the line. When the war ended, attention returned to battles and leaders, to decisive moments and famous names. But beneath them all remained the steady truth revealed by that factory's rhythm: once a nation learns to replace what is destroyed faster than it can be destroyed, time ceases to be neutral. And in a war measured not by days, but by endurance, that realization proved decisive long before the final shot was fired.